Everywhere there is a film, that one. So the film will be, now what action agent? Action agent, what will happen? It will do work. Will do work. He has to do any work. You see this. So action agent, what happen? Will come and pull this rod. So any displacement it has undergone the rod. You check it. So this will be the frame now. What are the assumptions? Let L be the length. Okay, there's a rod PQ. Action agent will slowly displace it. So let it have a displacement delta X. Are you seeing the rod PQ undergone displacement? As it is. So for this, what will happen? The action agent will slowly move the rod PQ from initial position to final position. This is the soap film. What happened? The area of the soap film has increased. Will agree? What you're seeing, shall I say, surface area has got increased. Surface area, it got increased, no? So then, from where these additional molecules will come? This soap film, again, you should have this imagination. What is this soap film? The soap film will be like this. It will be very thin. If I still plot it, no, it will appear like this. It will have two surface areas. This will be the top. This will be the bottom. What you're seeing is the top one. The bottom one will be on other side, and there'll be molecules. Able to imagine, all of you? Able to imagine? So this what happens here. Okay, now what we have done, the action agent has increased the surface area. From where these additional molecules will come on the surface? Below, inside only. From inside only. So now this particular molecule, now what should happen to it? It should rise to the surface. What will happen to adjacent molecules? The adjacent molecules, what happen, will oppose. So against the cohesive attractive force, what happen, the molecule has to rise up here. So therefore, shall I say that the cohesive force is doing work here. In fact, the action agent does work. The work done by action agent, what happened? It's got converted into increase in the energy of what? The surface energy. So here I'll put it like this. So here, let me write an external agent. Slowly pulls the rod to the right. From rest to rest. Initially it was at rest. Now also it is at rest. Then work done by external agent. What shall I write? F external into delta X. Now, any force due to surface tension, where do it will act? It will act at everywhere, no? Because all here molecules will be present. Make a practice of showing the molecules at the free surface. Actually, what you have to show? You have to show molecules everywhere here. Since I'm interested force acting on the rod, no, I'm showing the molecules nearby this one. Now, what are these bubbles, like a circles? They are the molecules which are on their own free surface that are in contact with the rod. How the force due to surface will act? Will not act one point, will act at all points, no? This is a force due to surface tension. It will also act here. Am I right? I'm not bothered on the wireframe. What is this? Somebody is asking, sir, what it is. It's a wireframe. And this green color is rod PQ. An X agent slowly pulls the rod to the right. Okay, there's a thing. Okay, let's come for this one. What is the, how much of force I should apply? 2 times of surface tension. Why 2 times? Anybody? Because there'll be free surface will be there on the top as well as on the bottom, no? Top free surface, bottom free surface. So now what is this? This will be surface tension into, what is the length of the rod? L. Surface tension. So what is this L delta X? Anybody? Shall I say increase in surface area? 2 times of that altogether. So this will be dW surface tension. What is this? This will be dA. I'll write it. So I'll bring one more definition. What is the surface tension? Work done per unit area. Work done per unit area to increase the surface area. So this also, now what is the unit for this? Joule per meter square. Work done is joule, area is meter square. So now I'll do work, no? See, you have to go back to the work point idea, that one. I'm an external agent. I'll slowly pull the rod. I'll do some mechanical work, no? Some my mechanical energy got, where do it, that energy gone? Converted into increase in surface energy. Now you can ask question, why the surface layer of a liquid will possess energy? For that, what happened? We have to go for some small explanation. Suppose if this is a tank, no, we had assumption, no? So this is the molecules like this. Now, if I want to increase the surface area, tell me what happened to number of molecules on the free surface? Should increase, no? If I want to increase the surface area, the number of molecules on free surface should come. Where that extra molecule will come? Should come from inside the liquid. So this molecule, it has to go and occupy this position. So when it is moving like this, when it is having a displacement like this, when it's having a displacement here, tell me like a net adjacent molecules in what action they'll exert a force. All these molecules in what direction they'll exert? They'll exert a force in this direction. Net resultant force, how it will be? This, and what is the force exerted by one molecule on another molecule? That we should call a cohesive force. So the net cohesive force in what action will be acting? The net cohesive force will be acting in, I'm trying to give the diagram because in books very badly the diagrams are missing. So that's why I'm trying to give. Look at this one. Net cohesive force in what direction will be downward. Then how is the displacement of the molecule? I'll write y, delta. The displacement is y. And tell me like how do this cohesive force will act opposite to displacement? And what is the, why I should call cohesive force? Because this molecule will exert force on this one, no? This molecule will exert force on this one. So So therefore, the net cohesive force will act opposite to displacement. And moreover, this cohesive force does work. And because of that weapon, energy got increased. So therefore, what shall we take this force due to cohesive force? Shall we take this as a conservative force? Yes, this was the example. I wanted to bring the idea of conservative force here. So the force due to surface tension, which is acting on the rod or between the layers, whatever be that one. This force, how do it will act? It will act tangential to surface. You can see here. And also it's a conservative in nature. Able to get this one? Any reason for that? Because if a conservative force does negative work, energy increases. Now you can ask questions from how energy increases. You have this particular proof. Now the surface energy, please do put effort. Please, I'm explaining concept. Surface energy, where it is more, in the first diagram or second diagram? In the second diagram. So I had to write a comment. Just small ideas are there. There's a surface energy of a film. This is very important. I'm telling this one. This is very important. Many problems, this concept will help us. That's why I'm bringing all supportive diagrams. Look at this one. Surface area increase. See yellow color. See all of you. Please don't imagine very big because I'm coming with a diagram, sir. Where you see yellow color layer in the second diagram, it is increasing. Then more number of molecules should come on surface. From where extra molecule will come? The molecules which are there inside should rise up. Then the molecule which is there inside, net force will be 0. Now what will happen? As I increase surface area, then the molecule which is there inside should rise up to the surface. Then this molecule, it is in equilibrium. Okay, fine. Now it has to rise up, means somebody should help him, no? So what is that somebody help? The external agent energy. The external agent, what it does work, with that energy is given to this molecule. Sir, how it is? Okay, that is a nature's phenomenon. Able to understand? There is a nature's phenomenon. So this molecule weapon has to come to the surface. So then these molecules will not permit. So somebody should help him. The work done by external agent, what happen? Its energy what happen will be made available to this. That is what the nature's phenomena occurs here. Fine. Now, why it should need energy? Because these adjacent molecules will not permit. So it should overcome this net cohesive force and it should rise up. And now you can ask questions, sir, what about here molecules? I'm talking about it is rising up. It is rising up means the net force should be downward. Against, and how do this cohesive net cohesive force will act? Opposite to displacement. So it does negative work. And what happened? The surface energy of film will increases. So therefore, the cohesive force did negative work and energy got increased. So therefore, this is a conservative force. You go back to the work per energy. If a force does negative work, energy increases, potential energy increases, gravitational potential not here, surface energy here. Then it should be a conservative force. This is the idea you have to recollect from work done. So therefore, what is the conclusion? I make it here now. The force due to surface tension, what it is? It's a conservative force. When it does negative work, surface energy increases. When it does positive work, surface energy decreases. And if surface area increases, surface energy increases. Surface area decreases, surface energy decreases. Free surface I'm talking. The layer of liquid exposed to atmosphere. There's a diagram I just took for example, why net cohesive force will be downward. You should think about these things supporting here. So earlier there are how many, say 1 lakh molecules are there. Now 1 lakh 20,000 molecules are from where that extra 20,000 molecules has come, should come from inside the liquid. That's all. Then when that molecule is rising up, the adjacent molecules will oppose. So cohesive force will act opposite to displacement. Cohesive force does negative work. So surface energy got increased. So therefore it is some sort of like a conservative force idea. So therefore now what shall I put it here? Cohesive surface as surface area increases, surface energy also increases. These are some very important points I'm summarizing. Next again, as the same idea, no? as surface area decreases, surface energy also decreases. Okay, this one. Next again, cohesive force is a conservative force. Fine. So these are very important. So these are the things which are going to help us a lot in numericals. When a cohesive force does like a positive work, surface energy increases. Next, we'll write here. Increases when cohesive force does negative work. Similarly, surface energy decreases when cohesive force does positive work. Okay, fine. So these are the most, you can say, the very important thing now. So like this, what happened? To construct a surface area, you have to do any work. Yes, we have to do work here. Extagent has to do positive work because surface area increases, surface energy will increase. So now tell me like what all the extagent did work, where it has gone, it got converted into increase in surface area of the liquid or surface energy of a liquid here. And now I'll ask you simplest questions. I want to construct a drop. What work the extagent should do? What is a liquid drop? All of you seen liquid drop? A good example. I think when you ask you to put high drops,